Right now, 4.5 billion kilometers from where you're sitting, there is a planet where it rains diamonds. Not metaphorically, not symbolically. Actual crystallized carbon squeezed out of methane molecules by pressures so extreme that they compress carbon into gemstones, falling like rain through an ocean of superheated fluid in complete darkness. But that's not the terrifying part. Neptune has the fastest winds ever recorded on any planet in the solar system. 2,100 kilometers per hour. That's supersonic. Faster than a bullet fired from a rifle. Faster than any hurricane, any tornado, any atmospheric event ever measured on any world we've ever studied. And here's the part that keeps physicists awake at night. Neptune is the farthest planet from the Sun. It receives 900 times less energy than Earth. There is almost no energy to drive those winds, and yet they blow faster than anywhere else in the solar system. Nobody fully understands why. Neptune has a magnetic field so broken, so wildly misaligned with the planet itself, that it tumbles chaotically through space like a drunk compass. It has storms the size of Earth that appear from nothing and vanish without a trace. And it has a moon, captured billions of years ago, that is slowly spiraling inward, falling closer and closer until Neptune's gravity will rip it apart and turn it into a ring of debris. Neptune is not what you think it is. It's not the quiet blue dot at the edge of the solar system. It is the most terrifying planet we know. And today, we're going to show you why. If you're the kind of person who looks up at the night sky and wants to know the raw, unfiltered truth about what's really out there, you're in the right place. This is Final Frontier Space. Hit that subscribe button right now. Tap the bell so you never miss a deep dive. And drop a like on this video. It genuinely helps us bring you more journeys like this one. All right, let's travel to the edge of the solar system. Chapter 1. The planet that was found by math. Neptune is the only planet in our solar system that was discovered not by looking through a telescope, but by solving an equation. By the 1830s, astronomers had a problem. Uranus, discovered in 1781, wasn't behaving. Its orbit didn't match the predictions. It was speeding up where it should have been slowing down and drifting off course in ways that Newton's laws couldn't explain, unless there was something else out there. Something massive. Something unseen. Something pulling on Uranus from the darkness beyond. In 1845, a French mathematician named Urbain Le Verrier sat down and did what no one had done before. He calculated exactly where this invisible planet had to be. Not approximately, exactly. He used nothing but the gravitational wobbles of Uranus, Newton's equations, and months of painstaking calculation by hand. On September 23rd, 1846, Le Verrier sent his predictions to the Berlin Observatory. That same night, astronomer Johann Galle pointed a telescope at the coordinates Le Verrier had provided. Neptune was there, less than 1 degree from the predicted position. Think about that. A man found a planet the size of 4 Earths, 4.5 billion kilometers away, with a pencil and paper. He didn't see it. He didn't photograph it. He calculated it into existence. Neptune's discovery was the single greatest triumph of Newtonian physics. Proof that mathematics could reveal invisible worlds. But what mathematics revealed was a planet that would challenge everything thought we understood about how worlds work. Neptune sits at an average distance of 4.5 billion kilometers from the Sun, 30 times farther than Earth. Light from the Sun takes over 4 hours to reach it. Noon on Neptune looks like deep twilight on Earth, a dim, ghostly blue haze where the sun is just another bright star. It takes Neptune 164.8 Earth years to complete a single orbit. When Neptune was discovered in 1846, it hadn't yet completed one full trip around the sun since its discovery. It didn't finish that first orbit until July 2011. 1 year on Neptune spans the entire history of photography, aviation, nuclear energy, space travel, and the internet. And in all that time, in all those billions of kilometers of cold, dark emptiness, only one human-made object has ever visited Neptune. Just one. Chapter 2. The Impossible Winds. When Voyager 2 flew past Neptune on August 25, 1989, it measured something that broke our models of planetary atmospheres. Wind speeds of 2,100 kilometers per hour. Let me put that in perspective. The strongest hurricane ever recorded on Earth, Hurricane Patricia in 2015, had peak winds of 345 kilometers per hour. Neptune's winds are more than 6 times faster. They exceed the speed of sound in Neptune's atmosphere. These aren't storms. These are permanent features, jet streams of unimaginable velocity that wrap around the entire planet and never stop. Now, if Neptune were close to the Sun, this might make some sense. Solar energy drives atmospheric circulation. More energy, more heat differential, stronger winds. That's how it works on Earth. That's roughly how it works on Jupiter and Saturn. But Neptune receives 900 times less solar energy than Earth. It is the least heated planet by the Sun, and yet it has the fastest winds. This is one of the great unsolved mysteries in planetary science. The leading theory is that Neptune's extreme winds are driven not by the Sun, but by the planet's own internal heat. Neptune radiates 2.6 times more energy than it receives from the Sun. Something deep inside the planet is generating enormous amounts of heat, and that heat creates powerful convection currents that drive the atmosphere. But here's the counterintuitive part. Some scientists believe the winds blow so fast precisely because Neptune is so cold. Less solar heating means less atmospheric turbulence. Less turbulence means less friction, and less friction means the winds, once they start, have almost nothing to slow them down. Neptune's atmosphere is so cold and so smooth that it becomes a nearly frictionless engine for wind. It's a world where the absence of heat creates the most violent atmosphere in the solar system. The emptiness itself is what makes it terrifying. Chapter 3. The Ghosts in the Atmosphere. When Voyager 2 photographed Neptune in 1989, it found a storm that looked hauntingly familiar. A massive, dark oval feature in the southern hemisphere, roughly the size of Earth. Scientists named it the Great Dark Spot. It looked like Neptune's answer to Jupiter's Great Red Spot, a giant anticyclonic storm rotating counterclockwise, with winds around its edge reaching 2,400 kilometers per hour, the fastest ever measured on any planet. Bright white clouds of methane ice hovered along its edges, pushed upward by the storm's circulation, like cirrus clouds on the rim of a hurricane. A smaller storm, nicknamed Scooter, raced around the planet below it, completing a full lap around Neptune every 16 hours. And then, 5 years later, the Great Dark Spot was gone. When the Hubble Space Telescope turned its gaze toward Neptune in 1994, the Great Dark Spot had vanished. Completely. No remnants, no fading echo, no trace that it had ever existed. A storm the size of our entire planet had simply disappeared. But that's not all. Hubble found a new dark spot in Neptune's northern hemisphere, a completely different storm in a completely different location that had formed out of nothing in the years since Voyager's flyby. Since then, we've observed multiple dark spots appearing and disappearing on Neptune. In 2018, Hubble watched a dark vortex slowly shrink and fade away in real time. The first time we'd ever observed one of these storms dying. Jupiter's Great Red Spot has been raging for at least 350 years. Saturn's hexagon has persisted for over 4 decades. Neptune's storms come and go like ghosts. They materialize from the blue depths, grow to planetary scale, and then dissolve back into nothing. We have no way to predict when the next one will appear. We have no way to predict when one will disappear. Neptune's atmosphere is a place where Earth-sized storms are born and destroyed on timescales of years, as if the planet is dreaming violent dreams and then forgetting them. Chapter 4. Diamond Rain. If you could somehow descend into Neptune's atmosphere, you would experience something that belongs more in science fiction than in reality. At the cloud tops, the temperature is minus 218 degrees Celsius. That's only 55 degrees above absolute zero. One of the coldest measured temperatures on any planetary surface in the solar system. The atmosphere is about 80% hydrogen and 19% helium, with small amounts of methane. It's that methane that gives Neptune its stunning, deep blue color, far more vivid and intense than Uranus's pale blue-green. Methane absorbs red light and reflects blue, painting the planet in a shade of cobalt, so deep it almost looks electric. Neptune is the most beautiful planet in the solar system, and what lies beneath that beauty is monstrous. As you descend, the temperature rises rapidly. The pressure climbs. Within a few hundred kilometers, you pass through clouds of hydrogen sulfide, ammonia, and ammonium hydrosulfide. The smell, if you could survive long enough to notice, would be overpowering, a combination of rotten eggs and industrial chemicals. Deeper still, and you enter a region that has no equivalent anywhere on Earth. Neptune is not a gas giant like Jupiter or Saturn, it's an ice giant. Below its hydrogen-helium atmosphere lies a massive mantle of superheated water, ammonia, and methane, compressed into a hot, dense fluid that scientists call ices, even though they're far too hot to be frozen. Temperatures in this mantle reach 5,000 degrees Celsius, hotter than the surface of many stars, and the pressure exceeds, level equals moderate, greater than 200,000 atmospheres. And this is where the diamonds form. At these extreme pressures and temperatures, methane molecules are torn apart. The carbon atoms are squeezed together so violently that they crystallize into solid diamond. Those diamonds then fall like rain through the superheated fluid, sinking deeper and deeper toward the planet's core. This was theoretical for decades. Then, in 2017, scientists at the ESLAC National Accelerator Laboratory used the LINAC Coherent Light Source, one of the most powerful X-ray lasers on Earth, to recreate the conditions inside Neptune. They blasted a polystyrene target, made of carbon and hydrogen, with optical lasers to generate extreme pressure and temperature, then used the X-ray laser to observe what happened at the atomic level. They watched carbon atoms arrange themselves into diamond crystal structures in real time. Diamond rain is real. Follow-up experiments in 2022 went further. Researchers at the Helmholtz-Zentrum Dresden-Rossendorf added oxygen to the mix, making the conditions more chemically accurate to Neptune's interior. They found that the presence of oxygen actually made diamond formation easier, suggesting that diamond rain inside Neptune may be even more abundant than originally predicted. billions of carats of diamond falling through a superheated ocean of exotic fluid, in total darkness at 5,000 degrees with 200,000 atmospheres of pressure crushing in from every direction. And at the very center, a rocky core roughly the mass of Earth, baking at 5,200 degrees Celsius, wrapped in a mantle of fluid so dense and so hot that it behaves like nothing we can create on Earth for more than a fraction of a second. Chapter 5. The Broken Compass. Every planet with a magnetic field has that field roughly aligned with its rotation axis. Earth's magnetic poles are about 11 degrees from the geographic poles. Jupiter's are tilted about 10 degrees. Saturn's magnetic field is almost perfectly aligned with its spin axis. Neptune's magnetic field is tilted 47 degrees from its rotation axis. And it gets stranger. The magnetic field doesn't even pass through the center of the planet. It's offset from the geometric center by about 13,500 kilometers, roughly 55% of Neptune's radius, as if someone took a bar magnet, tilted it nearly sideways, and then shoved it off to one side. The result is a magnetic field that is completely unlike anything else in the solar system. As Neptune rotates, its magnetic field doesn't sweep around in a clean cone like Earth's does. It tumbles. The magnetic tail, the region of space behind the planet shaped by the solar wind, corkscrews wildly. The magnetosphere twists and writhes as the planet spins, creating a constantly shifting, chaotic magnetic environment. On Earth, our magnetic field creates stable radiation belts and shields us from the solar wind in a predictable way. On Neptune, the magnetic field is so distorted that different regions of the planet experience wildly different magnetic environments as it rotates. Some areas are briefly exposed to the solar wind, while others are shielded. The magnetic equator passes close to the geographic poles. Nothing is where you'd expect it to be. Why is Neptune's magnetic field so deformed? On Earth and Jupiter, the magnetic field is generated by convection in a metallic core. Liquid iron on Earth, metallic hydrogen on Jupiter. On Neptune, there is no metallic hydrogen layer. Instead, the magnetic field appears to be generated in the icy mantle, in that layer of superheated water, ammonia, and methane fluid. At extreme pressures, water becomes electrically conductive, and convection currents in this ionic ocean generate the magnetic field. Time equals 600 milliseconds / greater than, because this dynamo is located not at the core, but in a shell surrounding the core. The field is inherently unstable and asymmetric. Neptune's magnetic field isn't broken. It was never aligned in the first place. The planet's internal structure makes a stable, centered magnetic field physically impossible. Neptune doesn't just have extreme weather and extreme pressures. It has an extreme relationship with the fundamental forces of physics. Chapter 6. Triton. The Doomed Moon. Neptune has 16 known moons, but only one of them matters for this story, and it might be the most tragic world in the solar system. Triton. Time equals 500 milliseconds / greater than Triton is large, 2,700 kilometers across, bigger than Pluto. If it weren't orbiting Neptune, it would be classified as a dwarf planet in its own right. And there's overwhelming evidence that's exactly what it used to be. Triton orbits Neptune backwards. Every other large moon in the solar system orbits its planet in the same direction the planet rotates. Triton orbits in the opposite direction, a retrograde orbit. This is the single most powerful piece of evidence that Triton is not native to Neptune. It was captured. Sometime in the distant past, Triton was a Kuiper Belt object, a frozen world wandering the outer solar system. It passed too close to Neptune, and the planet's gravity seized it. The capture would have been violent. Tidal forces would have heated Triton's interior for hundreds of millions of years as its orbit circularized from a wild, elongated ellipsine into the near-perfect circle it follows today. That capture event likely destroyed whatever original moon system Neptune had. Any moons that existed before Triton arrived were either flung into space, smashed into each other, or absorbed by the intruder. Triton didn't join Neptune's family. It annihilated it. Today, Triton is one of the coldest objects in the solar system. Surface temperature, minus 235 degrees Celsius, only 38 degrees above absolute zero. Its surface is covered in frozen nitrogen, with patches of methane and carbon monoxide ice. But even at these impossible temperatures, Triton is geologically active. Time equals 600 milliseconds / greater than Voyager. 2 photographed geysers on Triton's surface. Plumes of nitrogen gas and dark dust particles erupting 8 kilometers into the thin atmosphere and then being swept downwind for over 150 kilometers. On a world where the temperature is barely above absolute zero, there are eruptions. The mechanism is likely solar heating of subsurface nitrogen ice through the transparent surface layer, creating pockets of pressurized gas that eventually burst through the frozen crust. Triton is so cold that even the faint warmth of the distant sun can cause explosive eruptions. But the most disturbing fact about Triton is its future. Because Triton orbits retrograde, tidal interactions are slowly draining energy from its orbit. It is spiraling inward. Slowly, imperceptibly, but inevitably, Triton is falling toward Neptune. In approximately 3.6 billion years, Triton will cross Neptune's Roche limit, the distance at which a planet's tidal forces exceed a moon's own gravitational cohesion. When that happens, Neptune's gravity will tear Triton apart. A world larger than Pluto will be ripped into billions of fragments. Those fragments will spread out into a ring system around Neptune, one that could rival or even surpass Saturn's rings in scale. Saturn's rings are dying. Neptune's rings haven't been born yet, and they will be made from the corpse of a captured world. Chapter 7. Voyager's last portrait. Only one spacecraft has ever visited Neptune, and it did so almost by accident. Voyager 2 launched on August the 20th, 1977. Its primary mission was to study Jupiter and Saturn, but a rare alignment of the outer planets, one that occurs only once every 175 years, allowed engineers to use gravity assists to extend the mission to Uranus and then Neptune. Voyager 2 reached Neptune on August the 25th, 1989, 12 years after launch. It passed within 4,950 kilometers of Neptune's cloud tops, the closest approach to any planet during the entire Voyager mission. In just a few hours of closest approach, Voyager 2 discovered everything we know about Neptune: the Great Dark Spot, the supersonic winds. The magnetic field tilted 47 degrees. Tritons, geysers, 6 new moons, 5 new rings. Decades of discoveries compressed into one fleeting encounter. The images Voyager sent back took over 4 hours to reach Earth, traveling at the speed of light across 4.4 billion kilometers. By the time we received them, the light was so faint that the Deep Space Network's massive 70-meter dish antennas had to strain to pick up a signal weaker than the heat from a household light bulb at that distance. And then, Voyager 2 kept going. Past Neptune, past Triton, into the void. Neptune was Voyager 2's last planetary encounter. After spending 12 years visiting 4 giant planets and dozens of moons, Neptune was the final stop, the last world it would ever see up close. 5 months after leaving Neptune, on February 14th, 1990, Voyager 1, its twin, turned its camera around and took the famous pale blue dot photograph of Earth from 6 billion kilometers away. Carl Sagan's immortal words about that image, a mote of dust suspended in a sunbeam, were inspired by a mission that ended at Neptune's doorstep. No spacecraft has returned to Neptune since. That was 36 years ago. Everything we've learned about Neptune since 1989 has come from Earth-based telescopes and the Hubble Space Telescope, peering across billions of kilometers of empty space. There are proposals for a Neptune orbiter mission. NASA's Planetary Science Decadal Survey has identified a Uranus orbiter and probe as a top priority, with Neptune as a compelling follow-up target. But even if a mission launched tomorrow, it wouldn't arrive at Neptune for 12 to 15 years. Time equals 500 milliseconds / greater than Neptune is so far away that even going there is an act of generational patience. The scientists who designed the mission may not live to see it arrive. Chapter 8. Why Neptune Terrifies. Neptune terrifies because it is the planet that refuses to make sense. It's the farthest planet from the Sun, yet it has the fastest winds. It receives almost no solar energy, yet it radiates 2.5 times more heat than it absorbs. It rains diamonds in its interior through an ocean of superheated fluid at 5,000 degrees. Its magnetic field is tilted nearly sideways and doesn't even pass through the center of the planet. Its storms appear and vanish like hallucinations, and its largest moon is a captured world slowly spiraling toward its own destruction. We've visited it exactly once for a few hours with a spacecraft built in the 1970s. And in those few hours, it shattered our assumptions about what a planet at the edge of the solar system could be. We assumed the outer solar system would be quiet, cold, dead, boring. Neptune proved us wrong in every possible way. It is a world of extremes that shouldn't coexist. Unimaginable cold and scorching internal heat, breathtaking beauty and terrifying violence. A sapphire jewel hanging in the darkness that would crush, freeze, and shred anything that dared to approach. And it's out there right now, 4.5 billion kilometers away, spinning once every 16 hours, raining diamonds into its own core, slowly devouring its captured moon. Silent, distant, terrifying. Maybe the most important thing Neptune teaches us is this: distance does not mean safety. The farthest world is not the gentlest. It is the most extreme, the most mysterious, and the least understood planet in our solar system. Neptune is the planet we know the least about, and everything we do know terrifies us. Imagine what we'll find when we go back. If this video changed the way you see Neptune, do me a favor. Hit that like button. Share this with someone who thinks space is boring. And if you haven't already, subscribe to Final Frontier Space and ring that notification bell. We go deep into the worlds that nobody shows you, and we do it every single week. I'll see you in the next one.